we're going to look a little bit at permutations and combinations, and I think this chart is helpful when it comes to that. Now it says pick a permutation. So a permutation is an arrangement of items in a particular order without repetition. And a combination is a selection of things in any order. So when I think of the difference between permutation and combination, for me, permutation means a specific arrangement. Order does matter. You're putting them in a certain order. That's a permutation. Combination is really just a combination of something. A combination in any order doesn't really matter. And it does give you the long way or the equation for each, but really all you guys are going to do is type them into your calculator as NPR or NCR, and I will show you guys that when we get to it. But it goes down through there and it says like permutations are arranging people, digits, numbers, alphabets, letters, colors, but they're in an arrangement. And combinations is really a selection of something. So when the order does matter or it has to be a certain way, that's usually permutation. And when it's just a selection or you're choosing a number of things, that's usually combination. And then it says there for multiple events, in more complicated situations, you can just use the fundamental counting principle with or along with the permutations and combinations to determine the number of possibilities. So it gives you guys an example down there. It says if I have a class with 15 boys and 10 girls and I want to send 2 boys and 2 girls to represent our ALS 2 class in the UN. So we can use different things that we've learned together when we're trying to find the number of arrangements or combinations for something, but we will look at that. So for calculating the permutations of something, it says how many permutations are possible, and remember permutations is just a word for arrangements, are possible for the letters A, B, C, and D. So since there are 4 letters, we could do, and 4, pick 4, but for permutations, because the order is important and we're using all 4 of those, we could also do 4 factorial, like 4 times 3 times 2 times 1. For permutations, both of those work. 4 pick 4 or 4 factorial are the same thing. But it's going to be 24 different permutations for those 4 letters. So what about number 2? The starters for a 6-woman volleyball team have to be listed in a particular order, 1 through 6. If there are 13 women on the team, how many possible starting lineups are there? So if there are 13 women and we're picking 6 of them, we would do 13 pick 6. You could also, again, just for permutations, do the fundamental counting principle. So for the first 6 positions, 13 to choose from for the first position. Then once you've chosen that position, there would be 12, and then 11, and then 10, and then 9, and then 8. You would then have filled your 6 positions, and that would give you your number of ways to choose the 6 women. So 13p6 or 13 times 12 times 11 times 10 times 9 times 8. Either way, you get 1,235,520 different ways. And number 3, it says find the number of distinguishable permutations of the letters in mathematics. So the first thing when we're trying to find permutations or arrangement of given letters in a word, the first thing you want to do is list out the number of times each letter appears. So like the letter M occurs twice. A occurs twice. T is twice. H is once. E is once. And we already got A, we already got T, we already got I is once. C is once, and S is once. So what we do is we take the total number of letters in the word mathematics, so that would be 11. We say 11 factorial, 11 possibilities for those letters, now divided by all the possible combinations there are for each individual letter. So you can do all of your letters. So for M, it would be 2 ways, 2 factorial A, 2 factorial T, 2 factorial. And you could do H and I and C and S, so 1 factorial, 1 factorial, 1 factorial, 1 factorial. But what happens is because it's 1 factorial, it's really just 1. So you only need to include the letters that occur more than once. So what you do is 11 factorial divided by 2 factorial times 2 factorial times 2 factorial. So when you do this, just make sure that you're dividing by all of those in parentheses. That denominator needs to be in parentheses. And you end up with 4,989,600 different arrangements or distinguishable permutations, distinguishable arrangements of those letters in the word mathematics. Number 4, it says, a shelf can hold 7 trophies. How many ways can the trophies be arranged if there are 10 trophies available? So, we've got a total of 10. We're picking 7. So 10 pick 7 is going to be 604,800 ways to arrange the 7 of 10 of your trophies. Number 5, a teacher wants to write an ordered 4-question test from a pool of 12 questions. So how many different forms of the test can the teacher write? So we've got how many questions? 12. We're picking how many for the test? 4. So 12 pick 4 is going to be equal to 11,880 ways to make that test. And your last one, find the number of ways that 10 cheerleaders can make, I think that should say can make a circular formation. So if we have 10 cheerleaders and we're using all of them, it doesn't say how many we want to use for the circular formation. It'll just be 10p10 or 10 factorial, but it will end up being 3,628,800. And again, all I did here is type these right into the calculator. And that's it.